Welcome to SQL Fundamentals. Whether you're just starting out or looking to strengthen your database skills, this lesson is designed to give you a solid foundation in the language that powers data retrieval and manipulation. In this lesson, we will learn how to extract, filter, group, and combine data step by step. You'll discover how to retrieve specific information from large data sets and organize it in meaningful ways. We will also practice common interview concepts like joins, aggregations, and null handling. These are essential skills for any data professional as they form the backbone of efficient and accurate data analysis. By the end, you should feel comfortable reading and writing basic SQL queries. With practice, you'll be able to navigate databases with confidence and start exploring the vast world of data. This slide introduces three core SQL tools: select, where, and order by. These commands are essential for querying and managing data stored in a database. Select is used to specify which columns or fields we want to retrieve from a table. It acts as the main command that tells the database what information to display. Where is responsible for filtering the data by removing any rows that do not meet a specific condition. This helps narrow down the results to only the relevant records. Finally, order by is used to sort the output in either ascending or descending order based on one or more columns. By combining these three commands, users can efficiently extract clean and meaningful data from a table, making it easier to analyze and understand the information stored within. Whether you're working with small datasets or large databases, mastering these tools is a crucial step in learning how to work effectively with SQL. Group by is a powerful feature in SQL that allows us to take multiple rows of data and combine them into a more manageable and meaningful set of results. This function is especially useful when we want to analyze data based on specific categories or groups. For instance, imagine we have a table containing all the orders placed by different customers. When we apply group by with the customer's identifier, such as their customer ID or name, all the orders from the same customer are automatically grouped together. This makes it easier to look at each customer's activity individually. Once the data is grouped, we can use aggregate functions to gain deeper insights. The sum function, for example, helps us calculate the total sales made by each customer, giving us a clear picture of their overall spending. At the same time, the count function tells us how many orders each customer has placed, which can be helpful in identifying frequent buyers or understanding customer behavior. This approach is not only efficient, but also one of the most essential concepts in SQL. It forms the foundation for many complex queries and is widely used in data analysis, reporting, and decision-making processes. Whether you're working with small datasets or large databases, mastering group by and its associated functions is crucial for anyone looking to extract valuable information from their data. A very common SQL interview question is the difference between where and having. Many beginners often confuse these two clauses, but understanding their distinct purposes can greatly improve your ability to write efficient queries. Where works before grouping, so it filters raw rows. It is used to specify conditions that individual rows must meet in order to be included in the result set. For example, if you want to select only those employees who earn more than $50,000, you would use the where clause to filter out the rest. Having works after grouping, so it filters the aggregated results. This means it is applied to the results of aggregate functions like sum, count, AVG, etc. For instance, if you want to find departments where the average salary is above a certain threshold, you would use having to filter those groups based on the calculated average. If you remember the order of execution, this difference becomes very easy to explain. The where clause is processed first, filtering the data before any grouping occurs. Then, after the data has been grouped, the having clause comes into play, allowing you to apply conditions to the grouped results. This logical sequence helps clarify why each clause is used in different stages of query processing. Joins allow us to combine information from different tables, making it easier to retrieve and analyze data that is spread across multiple sources. By using joins, we can create a more complete picture of the data by linking related records together. An inner join returns only rows that match in both tables, meaning that if there is no corresponding entry in one of the tables, that row will not appear in the result. This type of join is useful when you want to ensure that all the data you are retrieving has a direct match in both tables. A left join returns every row from the left table, even if no match exists on the right. This means that if there is no matching record in the right table, the result will still include the row from the left table, with null values for the columns from the right table. This makes left join particularly useful when you want to see all the entries from one table, regardless of whether they have related data in another table. That is why left join is often used to find customers, products, or records with missing related data. For example, if you are looking at a list of customers and want to check if they have placed any orders, a left join between the customers table and the orders table will show all customers, including those who have not placed any orders. This helps in identifying gaps in data and understanding the relationships between different sets of information. Case when allows us to define specific categories or groupings right within our SQL query, making it easier to organize and analyze data without needing extra steps. This feature is especially useful when we want to classify data based on certain conditions, such as grouping sales by region or categorizing customer feedback as positive, neutral, or negative. By using case when, we can create custom logic that fits our specific needs, which adds a lot of flexibility to our data processing. Handling null values is crucial because they can significantly affect the accuracy and interpretation of our results. In many cases, missing data might lead to incorrect conclusions if not properly addressed. For example, if we're calculating an average and some entries are missing, the result might not reflect the true situation. That's why it's important to understand how different functions behave with nulls and to handle them appropriately in our queries. COALESCE is one of the most commonly used functions to replace null values with a default or specified value. It works by checking each argument in order and returning the first non-null value. This makes it very handy when we want to ensure that our data is complete and consistent, especially when combining multiple columns or sources. Using COALESCE can help avoid errors and make our data more reliable for further analysis. It's also worth noting that COUNTIN counts every single row in a table, including those with null values, while COUNT column name only counts the rows where the specified column has actual data, ignoring any null entries. This distinction is important when we're trying to get accurate statistics, such as the number of customers who have provided their email addresses versus the total number of customers in the database. Understanding this difference helps us write more precise and meaningful queries. This final slide brings the main SQL fundamentals together in one practice example. By working through this example, you'll see how different SQL concepts come into play when analyzing data. The query groups orders by customer and calculates total sales for each one. This process helps you understand how to organize and summarize large sets of information efficiently. Understanding how to group data is essential for creating meaningful reports and insights from your database. If you can explain the execution flow and the differences between joins, filters, counts, and grouping, you are building a strong SQL foundation. Each of these elements plays a crucial role in retrieving and manipulating data. Knowing how they interact allows you to write more precise and powerful queries. It also helps you troubleshoot issues when results don't match expectations. The best way to improve now is to practice small queries every day. Consistent practice helps reinforce what you've learned and makes it easier to remember. Start with simple tasks like selecting specific data or filtering results, then gradually move on to more complex operations. Over time, you'll find that writing SQL becomes more intuitive and less intimidating. Keep challenging yourself with new examples and always try to understand why a query works the way it does.